Hello everyone, and welcome to NDT Talks, a platform bringing global experts together to share real insights, practical experiences, and honest discussions about the future of our industry. Before we jump in, a quick note: we have just released a special buyer's guide, which is everything you need to know before you buy your next UT system. This guide helps you make smarter, faster, and safer equipment decisions, all reviewed by industry experts. If you haven't downloaded it yet, I encourage you to grab a copy after today's session. It's designed to save your time, money, and a few headaches when evaluating new UT systems. So now let's get into this today's session. Our topic is one of the most exciting in NDT right now: robotics, automation, and how they are transforming inspections. We have an exceptional panel joining us. Junio Valerio, Managing Director from the United States of America Flyability, known for pioneering confined space drones with their LEO series. Thomas Gramberger from Phil, with over a decade of experience developing automated NDT and metrology systems for aerospace and beyond. Mr. Kushal Chetty, Business Development Manager at Edify Robotics, helping companies across EMEA and APAC regions adopt advanced robotic solutions. Mr. Saleh Al Alshaikh, NDT Division Head at International Maritime Industries and ASNT Level 3, leading quality and compliance across oil and gas. And moderating this session, we are making a little bit of history of NDT Talks over here. For the very first time, our discussion is being led by a woman moderator. Please join me in welcoming Adriana Najera from Valerio, not only an accomplished marketing and communication specialist, but also someone who's making NDT Talks look even more adorable today. And I must say, Adriana, you're looking very adorable right now. So, Adriana, over to you. Let's start the conversation.
Thank you so much. Hello, everyone, and welcome to this NDT Talk. It's really a pleasure for me to host this talk and to share the panel with all the experts that we have a quite variety of experts right here. So let's get started into the topic, if you will. So today we're really discussing if a drone or a robotics platform will ever get to have the same feeling of a human touch and would be able to replicate that into an industrial inspection. So today we would really discuss that topic from different angles, and we have experts that will share their opinion and also their experience from what they are looking at into the real environments today. So we're going to start opening the discussion about this, and the topic to get started is, since industrial inspections really need a feel that humans have, and for so many years industrial inspections have been having technicians and humans on ropes or in different dangerous sites that are able to look and feel in the moment. The topic would be, do we really think a robot or an automated industrial solution can have that sensitivity when it comes to detecting a crack, when it comes to looking at corrosion, for example? So I'm gonna start with Saleh Al to give his opinion, and he's an experienced NDT technician and has been on the field himself. What do you think about this first question addressing that? Will a robot ever get to have the same feeling that you have on the field? What is your opinion?
Um, Actually, for both a robot in this field, it will be not easy, because as a human being, we can adjust ourselves, if as per the standard regulation, and if there is any mistake or something, we can go back for that, and we can discussion for with the expert people, But if that robotic, once it get error, and we need to start from beginning, so it will be for us is a long process. So I'm always dependent on a human being, because a human being, it is the power of the working, regardless, the robotic. So I don't have that much, experience with robotic, but I already work with automatic, ultrasonic in phase array and TOF and Tesla, but still human being is the major impact in this field. This is my opinion.
Yeah, absolutely. And that is why this talk, it was so relevant, and it felt so realistic, because this is the conversations we're having in the industry right now, right? Like how to merge that bridge between human and solution and robotic solution. Are they really taking over or not? And your answer really goes along why we need a human behind these technologies. Thomas, do you agree? Because reading your experience, you're also quite in the field. You have an engineering experience also in NDT. So before we proceed to the masters of the robots, what is your opinion, Thomas? Do you agree also on what we are discussing right now?
Definitely, but first of all, I would like to maybe clarify a bit my view on this topic, because I think compared to the other colleagues in this call today, I'm coming from a different side, because I'm more focused on the stationary systems which are screwed down on the shop floor and used for the production of aircrafts for the quality insurance. And in this particular case, the use case is totally different. We are not having any crawlers or mobile robots which are coming to the parts to be inspected, rather than the parts to be inspected are coming to the stationary automated system. So this is maybe a different perspective, but also in this specific use case, we are having very, very challenging tasks which are not yet fully solved. And actually, one example is that most of the parts, or actually all of these parts, which are finally assembled to an aircraft, they have some deviations to the CAD, to the ideal world, to the nominal world. And the challenge nowadays in the field of production and quality assurance in production is to address this deviation from the nominal. Obviously, a human with a transducer in the hand would always move smoothly on a part, never, no matter whether it deviates from the CAD nominal or not. In case of an automated system, you need to feed in a program. And this program was nowadays mostly based on a nominal. Obviously, with these deviations we are creating some challenges. And this is exactly actually nowadays, we are investing the majority of our R&D budget on exactly this topic, to address this deviation from the digital world, where everything is ideal, you have nominal values, you can simulate everything, but in reality it is different. And this is maybe a common challenge we are all having here in this round. Nevertheless, you are more, let's say, bringing the inspection device, no matter whether it's manually guided or robotic guided, to the part to be inspected.
Right. So over there, we have a very interesting approach from you, Thomas. Thank you for bringing that up. But really, these robots bring in a level of difficulty, added data that is in a good way positive, to add more information, or it's just complicated the system. So Junio, what is your take? Because Junio, you are into the field of confined spaces with drones, really, removing a lot of these hardasses and situations where we don't want humans to be. What is your take on this topic? First question, on will your drones and mobile robots ever have that touch and sensitivity to approach and get adjusted to the environment that they are surrounded?
Well, first of all, I wanted to thank the organization for arranging this webinar, and I wanted to thank you, Adriana, for monitoring. Very grateful for the opportunity to OnestopNDT to discuss this very interesting subject. I think, Adriana, you're right to distinguish that at Flyability we approach this challenge in a slightly different way, because our technology by default tends to get deployed in places where humans shouldn't go in the first place. More often than not, actually by legislation. So I think we have an increased obligation towards us user or our users to make sure that the technology can substitute or accompany the experience of human experts with our robots. I think that I think this question nowadays has to be read, especially when we talk about robotics, has to be read in the broader context of what's happening in the robotics field in accompaniment with the artificial intelligence. I think that if you were asked the same question 4 or 5 years ago, I think the answer would have been a lot more straightforward in terms of no, absolutely, that sort of the human experience, the collection of human experiences that an NDT inspector can bring to the field, it's absolutely not replaceable with robots. However, with the giant leap forwards that are being made in the field of AI, specifically image defect recognition, but in general also large language models. But I think that image recognition for NDT is way more significant. I think it's not out of the realm of possibility that we'll be able to condense in a matter of years hundreds of thousands of NDT reports and essentially teach the robots to recognize and understand the difference between different kind of corrosion, different kind of defects on surfaces. And this is going to be a gradual process. I don't think it's going to happen overnight. But I do believe that with the assistance, the help of artificial intelligence, a lot of these knowledge gaps will be covered.
Right. Thank you very much, Junio, for that very nice answer and putting a picture into the influence on like the robotics aspect, right? And moving a little bit closer to that too, we have also Kushal that from Edify Robotics. Kushal, you have been working very closely with asset owners too. You've been in the field and you have a lot of sense on like what sensors applied into robots can really do. What is your take on this first question?
Thanks, Adriana. I think there's quite a few levels to this in terms of what is applicable right now and, what are we looking at for the future, right? Right now, definitely not, right? We're not really anywhere close to it. But the reason why even companies like Viability and Edify Robotics and many other companies exist is because there are these dangerous environments where people are having to go to right now to perform inspections. And even if you can't get the exact same data set or the same type of data that you would get if a human was in that environment, you can still get a data set that leads you to being able to make a decision on these critical assets. And I think that's what can be really valuable. And what we're seeing now coming up more and more is not just being able to grab those data sets, but being able to get repeatable data sets, which means that you can make decisions based on those changes. That's something that humans somewhat struggle with because being able to perform the exact same task again and again is quite hard for a human without some kind of variation. Now, obviously, going into what Thomas was saying, the manufacturing industry, they would have probably more funding than we have right now to be able to develop solutions, and they're still struggling to be able to kind of incorporate computer vision to be able to vary the movement of an arm or whatever sensor carrying device they have to morph to the shape. So I think a lot of this is going to come from the industry need and want, and then there's going to be a lot of data required, a lot of AI machine learning that needs to be incorporated in before we get to a point where tactile sensors are being able to make sense of the environment that they're in and you're getting anywhere near what a human can do.
Totally. Yeah, that's so many possibilities that we can see. And I think it's exciting for every one of us in the industry involved to see that collaboration between human machine, right? And it seems, Kushal, you were kind of advancing into my next question. You were already talking about sensors. And we know humans are working with these sensors on their hands, and for the case of robotics is the robots carrying these different sensors, and we're talking about inspecting assets or inspecting environments that are critical for everything we do, from the energy we get from sourcing oil and gas for our cars to have enough gasoline to get transport to get our food. So it's really a vital task that we're talking about, and very often we realize what is behind all, what assets are taking care of this. So the next question is about the sensors. How advanced are the current sensors? And maybe later on, Junio, you can also elaborate on this question, following up Kushal, on how um, the data that we're getting from these sensors on these robots, how close is it, how exact is it to the data that humans are actually getting from these other sensors that we've been using for many years?
Yeah, it's actually a really interesting point. It goes to one of my biggest pain points, which is I don't think there's that many sensors being developed that are specifically for robotic systems. You're always trying to kind of incorporate something that's designed for a human into a robotic platform, and that's part of what's missing right now to an extent, where you don't have the ability to get the full range of advanced non-destructive testing capabilities in all robotic platforms, because there is a difference, right, between when a human is in a certain place versus a robotic system, how they're adhering to the area that they are, how they're moving in that area, and what the form factor of the probe is like will make a big difference in that. So, in the sense of, if we're talking about one type of NDT being deployed in a specific place, and whether a human did it or a robotic system did it, there's a lot of variables which can make a difference there. But if it is, something that is compliant with current technology, then you're able to get a very similar data result.
Mm-hmm. Yeah. And in Junio, for example, we have the Elios working in confined spaces for the non-destructive testing, particularly for the UT, right? The UT readings. What are we looking at here in terms of this, discussion right now that Kushal brought about sensor and data accuracy?
Well, I think Kushal raises an excellent point. I think right now it's been sort of the world of robotics that had to adopt to the world of NDT and basically retrofit or fit the existing modules onto the robots. But it's basically the work of robotics companies like Flyability or Valerio, for that matter, to fit existing NDT technologies on new robotics platform. I think that's a given, considering that again, NDT industry has been around for a lot longer than drones. Going forward, I think it's going to be interesting to possibly see not necessarily a reversal, but an adaptation of the NDT industry towards robotics. So basically, NDT companies working more closely with a robotics provider in order to make sure that their technology fits drone and robots rather than the other way around. When we go into the topic of data, I think it's interesting to reflect upon the fact that with the use of robots, we've basically opened the floodgate for a quantity of data points that is absolutely unprecedented. So compared to what previously NDT inspectors were able to capture in the same time frame, the current robotics platform, I think, can easily increase the number of points of single data points exponentially. This creates an obvious issue with the review and analysis of these data points, where again, I think that currently the human eye and the human experience, it's an absolute necessity. But again, going forward with the utilization of artificial intelligence, there is already some very interesting examples on this. For instance, on wind turbines and other very similar replicable assets. Going forward, I think artificial intelligence can really help to determine to distinguish sort of in the noise of all the data that has been captured, what is actually relevant, what is valid, what is false negative, and most importantly, I think also how to aggregate this information and how to distribute it efficiently and effectively among the right stakeholders. I think that's really where a lot of value currently is not being delivered or is being lost, let's say. There is definitely a lot of data, a lot more data that is being captured, but it's not necessarily being analyzed effectively and efficiently, and it's not being distributed in the right way.
If I'm allowed,
Absolutely, yes.
sorry, I would like to bring another maybe perspective on this discussion about sensors, because obviously, if you would like to inspect a surface with an automated system, you need some feedback to this automated system, how to position this sensor accurately on the surface, mostly for UT inspection, obviously normal to the surface with a specific distance. And I think an underestimated potential in this specific case is utilizing the feedback of the process sensor itself for this positioning correction. Because typically, in many applications, you see a lot of sensors around the UT sensor on an end-of-arm tool of a robot, like structured light scanners providing point cloud information, distance sensors, potentially tactile or contactless, or even LiDAR sensors, with the purpose to kind of reconstruct the surface to be inspected, either in real time or prior to inspect. But nevertheless, the process sensor itself, the UT transducer, is already providing so many data which can be utilized in real time to adapt the inspection trajectories. This is something where we are focusing at the moment. It has several benefits because it has a very big benefit, a positive benefit in terms of costs, because there is no additional hardware needed if you use the process sensor also for this adaptation of the inspection trajectories. But obviously this, let's say, this view on this topic is mainly applicable for our industrialized system, where the part to be inspected is always, let's say, at least similar to the next part. Obviously, it has minor deviations.
Yeah, so basically what we're saying here is that these robots and all these technology really bring a variety of possibilities that collecting information in a faster and a simultaneous time can enable for later on technicians or inspectors that are in the field to concentrate on what this data really means, right? What is this data really telling us in a more bigger picture and not so central to just one aspect, right? Saleh, what is your opinion in this conversation we're having right now? It's very interesting. Do you think having more information, having more technical points in the readings is something vital for the industry, or is more like a luxury?
Actually, like my colleagues, what to say about it, especially the sensor, like it will be different, if you are working with manufacturers, or working for construction or for gas and oil. For each sensor will be different, like for those manufacturers, especially like by manufacturers, as my friend he said, when they focusing will be focusing the surface and what kind exactly they are try to look in for. If they want to like for surface indication, definitely they will use normal probe. I mean with 0 degree it will be different. Like if there is welding, it will be different techniques. They will try to use angles, waves, shear waves for that one. Okay, so I don't have that much experience with robotic or this much, but one time I've been attending one because we have some requested from our contractor, for modifying special pipe for us. So they use sensors for ultrasonics, So for the robotic, the good thing is for production will be too high, for them, So they can produce many let's say product, let's say if we request 10 products, they can produce it with less time. This is the advantage for that one. But still, once there is some defect and they are not exactly, let's say they have doubt in that defect, still they will try to go for manually and try to cross check it and to clarify if that one defect relative to the indication or not indication. And this is the kind of that. So with this technology, it will be easy for us, to support us in our job. But still, sometimes that manual things or the human being in that part always is the impact, in that field. If my colleagues they agree with me,
Yeah, that's a very interesting approach to see. And also, as Kushal initially said, for the moment, there's going to be a lot of human involvement. Meanwhile, these technologies keep growing, right? And with AI and the adoption of physical AI, we're also going to look even more possibilities. Hopefully, a second round of this panel to see how that evolved. But let's move now into the next question that is talking about the environments that these mobile robots, but also people like you, Saleh Al, are in collaborating. So we can start with Junio for this one, for example. And the question is, how adaptable are these robotic systems to changing environments, such as like confined spaces, for example? We know in these spaces, anything can happen in any moment, right? Can be something going on there that is sudden and that the robot is not prepared to react on. How adaptable are these robots based on your experience at Flyability, but also from your network, what you're seeing around what others are developing?
Thank you very much for the question, Adriana. I think the level of adaptability it's already very significant over the course of the last 10 years. Speaking for Flyability's technology, we have been able to adapt to a multitude of incredibly dangerous situations, from nuclear power plant radiations to toxic environments in sewers to very unsafe underground mining environments. So I think that the design behind it definitely helps to meet some of the most difficult environments. I think when we talk about other kind of robotic technologies, for me it's been absolutely fascinating to see how some of the robot dogs have been able to adapt to environments as challenging as offshore platforms. This is definitely one of the most interesting applications in one of the most extreme and remote industrial areas with countless challenges in terms of the environment itself and the working conditions. So I think that the engineering behind this kind of innovations is proven to be incredibly adaptable, resilient, and also very much aware of the kind of conditions and situations that the users have to face. Same for outdoor drones. In a space of a few years, we went to systems that were very difficult to operate with unfair weather conditions outdoors to systems that can basically fly in almost all conditions depending on their usage. So the rate of adaptability of the technology has been absolutely fascinating, and I think it's only gonna grow from here.
Yeah, and maybe Kushal can also elaborate on this since you're working very closely to these environments that Junio just mentioned, such as nuclear sites, which just to think about the word nuclear is already intimidating, but robots can do and be in these environments without, and that's the type of environments where we don't want to have humans as much as possible, right? What is your take on this?
Yeah, I completely agree with Junio. Like, I mean, what we've seen over even just the last couple of years, even take flyability, for example, they've introduced some functionality called return to home, which automates the robotic system in a confined space and it's able to fly back, back. And if you block off its exit path, it relocates and looks for another way out. That is amazing adaptability in a otherwise impossible scenario or very difficult space. And even if a human was piloting it, it would probably be a more difficult task than the robotic system or the drone in that circumstance being able to maneuver out, just because it has more contextual data. And I think context is the big thing in all of this. When robots have a great amount of context involving the environment that they're in, they're able to make better decisions, granted that that intelligence has been added to them. But without this contextual information, it becomes quite difficult. So a lot of the adaptability is going to come from the kind of sensor payloads, the kind of AI capabilities that come in the future in terms of being able to analyze the environments that we're in. And like we said, right now, we do a lot in the nuclear space and with Edify, but it's still a person driving a robotic system which has a mechanical arm, which is then, maybe using a ratchet to unbolt something. But this is still a human having to intervene and align and make sure that everything's working. But as technology improves and you've got computer vision that gives the ability to the robotic systems to say this is where you are, this is what you're trying to do, I think there's a huge amount of expansion in this space. But I just wanted to say though, in terms of adaptability as well, one of the things that we have is that a lot of assets that are on sites are not necessarily designed for robotic systems to be able to access or inspect very easily. So I think that, it seems unlikely that, fundamentally many designs are going to change, but we are being reached out to more and more where people are saying we have an asset that we're going to be delivering in 30 years, for a nuclear plant or for ammonia storage tanks or something like that. And they're saying, we want this to be ready for robotic inspection. We want to design it so that robots can actually access and do the work. And that is a fundamental shift and change, because adaptability isn't about how do we make something work where a human can only work. It's about adapting the environment as well to making it work for a robotic system.
Absolutely. And that's why, all of your work here in this panel is so important, because this is bringing an open mind to all these people behind, the process of this. And maybe here I can bring on Thomas. You were saying, yeah, maybe you guys are not working directly into developing these robotic platforms that are flying or moving around. But I also see in your background, and correct me if I'm wrong, that you also have experience with simulation. So how important it is to test and simulate how these robotic platforms will work in these environments, and maybe you can bring a little bit more conversation between how we can improve the adaptability or the reasoning of these machines thanks to other more advanced simulations or training, let's say, for these robots.
Thank you. So prior to my comment about simulation, I would like to come back to the initial topic about adaptability, because this is also a key topic in the production industry. And as you can see behind me, this is an inspection robot, and it is carrying some UT transducers for scrotal UT inspection with rotor coupling in this specific case. And for some specific applications, it is also possible to think about just replacing the legacy inspection technology, which is in this case motor coupled UT, with a new alternative inspection method, which has different requirements. In this specific case, we can inspect this kind of parts with so-called laser-excited UT, so we can get rid of the coupling voltage, which helps also in some specific environments to reduce risks, to ensure accessibility. Sometimes parts in aerospace should not get wet for inspection. So nowadays, those parts are sealed, which is a very, very challenging task and time-consuming manual task. And with alternative inspection methods, you can get rid of this. So this is also an aspect. We call it multimodality. So our inspection system are not necessarily focused on ultrasonic, rather than having the entire palette of inspection technologies, which we can easily exchange fully automatically. So UT, laser-excited UT, thermography, X-ray, whatever, and all these modalities can be combined in an automated system. This is really the further down the road, the industry is looking exactly for this kind of multimodal solutions. So this is my comment on the topic before. About simulation, obviously in this industrial systems where you have some kind of a serial production of parts which are similar but not the same, with some slight deviations, it is really in the meanwhile, it is standard that you simulate all these inspections prior to occupy the asset on the shop floor with a real part and do the first trials, because you can parallelize the entire commissioning of such a system, but also the introduction of new parts on an automated system on the digital twin. And you can simulate, you can already predict cycle times, you can even simulate how the sound beams of the UT propagates into the specimen with specific tools. So if I compare the share of, let's say, digital simulation products of a NDT system now and 10 years ago, 10 years ago, for instance, the share of the mechanical of the robot itself, of the hardware, had a certain range, and in the meanwhile, the share of just digital input on such a project, may it be simulation, but also programming tools to assist the operators to run such a complex systems, has significantly grown. So obviously utilizing AI for specific tasks like vision processing. So this is quite important, and such a system, what you see behind me, could not be even commissioned on the shop floor without sufficient and simulation in the digital world prior to realize it.
That's a really brilliant aspect that you are bringing to this conversation, and also what you just said about this new UT technology to use in specific use cases, and that is also something very important. Saleh, what is your take on this, what we have mentioned so far about the adaptability? Do you have close experience looking at these robots adapting, or maybe looking at them having a challenge adapting to the environments we would have humans?
Actually, in my field, especially now my new field, we try also to start up with this technology, with robotic, or let's say mainly we try to start with the drones, because some point it will be very difficult for a human being to reach it, So now we are discussing during our startup, our production for big vessels like jackup rigs or ship, like bulk carrier or something, mostly after being fabricated and some point. So it needs some inspection kind of ultrasonic or ultrasonic, let's say, to see the weakest point in the top or something. For a human being, it will be not easy, because it will take time. It needs to build up scaffolding and man hours and everything. But with kind of this technology, it will save our time and it will be easy for us, to reach up. But still, we need to try this technology, from my side, because I'm not that much, but like my colleagues, they are very, very expert with this technology. And I hope to be with them in this technology, but still, in this part in our company still under discussion. Not that much. Because the cost, the timing, everything's for them. This is the main thing. So I hope to be, to be part of this technology to see what is the difference. Because my past experience only depending on a human being. So just recently we tried to develop our system for entering the data for after the inspection. We have the reporting. So now we try to use bots for, let's say, we just give them the data, and he will try to input the data in the system. But this one we are facing very difficulty, especially because that inventory, the tools, equipment, serial numbers, names, what kind of the equipment, it is not easy for us just to guide that robot or that bot just to input it in the system. So it is very big challenge and not easy, but it may with this let's say the developers, it will be from their side, they'll try to make it easy for us. So I hope, but still human being should be in the main things, to control all this technology, the artificial or the bots or everything.
Absolutely, yes. And what you're saying right now, it is actually not part of the prepared questions, but I think it's a very delicate and important topic. It's the how do we build trust between human and machine, right? Because machines will make mistakes, and especially these are robots that are being developed just in a couple of years. We don't have many years of having them deployed in these dangerous areas. We just have a couple of years where we have seen more and more asset owners, more and more service providers get comfortable using these technologies. So, Kushal and Junio, how do we bring this trust for users like Saleh Al to say, hey, let's give it a try, and after the robot makes a mistake, to be open and say, okay, this can happen, let's try it again?
Junio, you want to go or should I?
Kushal, happy to leave this to you first.
Sure. Okay. I do think actually, funnily enough, it goes off part of what Junio was saying earlier, which was the volume of the data that you can get out of using these systems plays a significant role in kind of the shift, which is right now, I guess, there is an undeniable advantage that humans have in terms of dexterity and tactile capabilities. However, there is a significant limit on where we can acquire data and how much data we can acquire. So I think as soon as that larger data set becomes more understood in terms of how much value it can bring, that's where we'll see a significant shift. And, I think you could probably see, Gecko Robotics is, everywhere. Everyone knows about them now. They've really leveraged just, they're not necessarily using the most advanced NDT modalities, but they're acquiring so much data and then running it through so much contextual analysis using AI that they're able to, really leverage a lot of benefits out of it. So I think that is going to be the thing that could possibly, shift the needle more than making people believe that, a robot is actually going to be able to function as well as a human, because frankly, it's not for a very long time.
Yes, that's about right. And we can end here the panel then with that answer. No, just kidding. Definitely, that's what is something that we will keep looking right now. This collaboration, that's very interesting that you bring it, Kushal, and you say contextual data. So going aligned with Saleh, making easier the human work into giving data, just like ChatGPT, right? Like nowadays we use ChatGPT literally for anything, asking even does this country needs a visa, I mean, we can go and read, but why not just ask? And I think this is what robots will bring as possibilities, just making ourselves be more analytical and enable more data for us to take decisions. So what about if anyone has another approach? Junio, did you want to also participate, or should we move on?
No, I appreciate the opportunity to answer this question. I think it boils down to three things: acknowledge the mistakes, listen, and improve. There is a quote from Samuel Beckett that comes to mind. That is, "Try again, fail better." I think this is sort of the short history of most robotics company. I think that the burden of proof is always on the innovators, right? So I think that it's up to companies like Pliability, like Anybotics, like Valerio, just to stick to Switzerland to demonstrate that we can do better than the current systems. We deal with people that are naturally embedded in a risk adverse environment. That's their bread and butter. That's their job. So obviously, in order for our technology to be fully accepted, it has to show an error level that is at least as low as the current methods. And otherwise, it's very difficult for operations manager, risk managers to accept this change. And the important path I think to follow is to realize that um, every single every single model, every single product is a prototype for the next generation. So again, if I think of how far the Helios has come in the short space of 8-9 years, it's absolutely phenomenal. So the ability of companies to acknowledge the limitations of the platform, to manage customers' expectations, and to incorporate that feedback into the next evolution, it's the only way to convince the skeptics.
Yes, yes, very. I also totally agree with you. It's all about collaborating very closely to each other and leaders, like, for example, what Thomas is doing on the field, what Saleh Al is doing in the field, really merging all those learnings to bring it to once the sensors and the robots we are deploying on the field. I don't know if everyone realized, but the time flew away. We are 10 minutes away from ending this session, and I still have another three questions to go. So I'm really struggling a little bit on like what question to tackle because I just feel everything is really insightful. I saw some comments on the chat, so maybe we also leave a little bit of time open if anyone in the chat has a exact question for someone in the panel that has certain expertise that you want to know. Please feel free to send it out. Otherwise, let's wrap it up. And over here, I think that the question is the future of robotics in NDT? And what is your personal opinion about this? Let's get started with Thomas. Sorry.
Yeah, obviously, definitely the future is with robots, and the robots are becoming more and more intelligent, but I'm having the opinion that we should not try to replicate the human rather than identifying the pain points in the inspection and find the best approach to solve these particular challenges. So this is kind of my general opinion on this topic because I've seen several approaches to just to simulate humanoid robots or trying to use humanoid robots, but I prefer the approach to analyze the pain point and to find the best and appropriate solution technically to solve it rather than trying to replicate it in a way a human would do it.
Very nice. Would someone like to lead on that next comment? Kushal or Junio or Saleh Al?
What specifically?
the question about it's robotics. Is the future of robotics in NDT, or are we just like maybe Thomas said it a little bit? Are we just kind of like trying to solve something that for now is not that like important? Let's say.
Right. No, I mean, I do believe that there is potential for a significant shift away from this current methodology. And if you just look at installed sensors, how widely they're being adopted now, which are instruments that either are giving continuous feedback or delayed or timed feedback, which gives another set of insight into, and I'm talking about active assets specifically, more than manufacturing. I think that there could be a fundamental shift, at some point, potentially, depending on whether, this kind of technology really evolves. And, we've seen it coming up over the years, even in, pipelines where they have fiber optics or other kind of sensors running along the pipeline so that they can tell if there's, some kind of damage or rupture or bends in them and things like that. So I think that, yes, there is definitely a place for NDT deployed by robotics, and I do believe it's going to grow more and more from where we are right now. But I also think that there's going to be a huge adoption of other types of sensing where you don't necessarily need to be interfering in the environment to be able to get your data back.
Absolutely. Maybe over here, I give it to Saleh Al. Are you excited in working together with more robots, with more sensors, such as like what we are, having here in the panel? We have a couple leaders that are dominating and showing the capabilities. How do you feel in the future of this? Getting more or less?
Yeah, it will be getting more definitely, but still, because I didn't use that technology, so it looks I'm for them I'm look like old fashioned, because not use this technology. But it will be very huge impact, very huge things will be for the future, because it will save many things, for our products, our everything. So, but still, because it is in the first stage, so it need our trust, So let's see, try. I would like to try, this thing, So let's see.
Yeah. So I just have to see before I give this to Thomas. I just have to say we have here two people that could send you a couple of products to test. Junio, Kushal, we have the network here for you to test it, to get enhanced. And like we say it here at Valerio, until you don't see it, do it and happening, you're not gonna believe it. So that's a step very important. Thomas, I think I have a question here that you might be the one and the right person to answer from the audience. This is from Roberto Passerini. He says, what is the regulatory pathway for certifying the transmission from manual NDT method for aerospace materials to a robotic and automated NDT system?
It is a very good question. By the way, Roberto, I know you. Glad having you here in the session. Actually, the topic is very important, obviously, especially in aerospace, where you need some certifications to ensure airworthiness of the aircraft, actually. And at the moment, there is this well-known concept about level 1, level 2, and level 3s, which are allowed, the level 3s ultimately allowed to sign off a procedure. Level 2 is allowed to sign off at least an inspection that it is done properly and evaluated properly. And we had a very similar discussion recently in another symposium. And actually, this topic is more and more becoming a topic in the NDT aerospace community, because the big question is whether, especially if you are utilizing some AI stuff to evaluate parts, who is at the end responsible for a false negative or false positive, whatever decision. And nowadays, even if you use the best algorithms to bring some decisions, at the end, a human must sign off this result. This is status quo nowadays. But obviously there are many discussions ongoing how this might change in the future, especially when AI will be introduced in the evaluation of the results. I mean, one last comment about the AI-assisted evaluation. In X-ray, for instance, the AI-assisted evaluation is state of the art since a long time, because it is just vision processing. But in UT, it's a bit different, especially when talking about composite materials, which is anisotropic, a very anisotropic material. It's even for an AI quite challenging to find in an automated way some indications. So the research is just on a very early stage on this topic, but obviously this is a very, very challenging and interesting discussion which is ongoing, and yeah, I will definitely have an eye on this in the next decade.
Very nice. We're giving there quite a timeline to see some progress, but totally right. We have to be careful and mindful that all these robots are.
I'm thinking in decades, because aerospace is conservative and slowly progressing.
Yes, please keep it like that. As we all, I guess, we use airplanes, right, in different solutions that, yeah, it's just strange the idea to have a human thousands of feet in the air. But yeah, all the possibilities that technology enables us to connect, to get to know our world and other stuff. We're 2 minutes away from closing this session. And if OnestopNDT team would like to jump in, or we just wrap it up at this moment with the last question, which is the most controversial, I would say, and let's try to keep it very short. Maybe we just have one or two opinions here on what do you guys think is going to be that one task that robots will never be able to replace humans in terms of, inspection, industrial inspections. This is very controversial. Maybe you don't even want to answer, but if someone wants to volunteer.
I think getting injured, which is why we should really aim at using robots as much as possible. A robot can get damaged but can get injured. Somebody before was mentioning in the chat, whether robot dogs come with floating devices on offshore platforms. They don't need to. I mean, at the end of the day, if they sink, they sink. Insurance is going to take care of that. And but you really can't. Well, we often say in this industry, you can't put a price on the value on human life. Turns out you can. Insurance companies certainly do it. Shareholders certainly do it. Stakeholders and stockholders definitely do it. So I think something in the inspection world that robots can never do is getting injured.
Very good. Yes, I also heard a very interesting sentence by someone last week in Las Vegas at the commercial UAV trade show. Someone said, I've seen many of my inspector colleagues, and I have to go to, their funerals, but I never been in a drone or a robot funeral. So that's a topic that you're mentioning right now is definitely something important. We need to keep working hard, and I appreciate everyone here on the panel for doing that great job. I've connected to everyone here, and I hope that the audience has had enjoy this panel. Ravinda, would you like to also jump in, or anyone from the OnestopNDT team, to kind of wrap it up this panel?
Yes. What a fantastic discussion. A big thank you to all our panelists, Mr. Junio, Thomas, Kushal, and Saleh, for sharing such practical, honest insights into how robotics and automation are shaping the future of inspections. And of course, a very special thank you to Adriana for moderating this so well and for guiding the session with such a clarity and energy. And finally, thank you to all our audience for joining us today. Don't forget, you can download our free buyer's guide, everything you need to know before you buy your next UT system, to help make better equipment decisions. So until next time, stay safe, stay innovative, and keep pushing the boundaries of NDT. So thank you, everyone. Thank you, gentlemen.
You.
Thank
Hope to see
So
you
much.
soon. Bye bye.
Have a
Bye
good
bye.
Thank you
day.
very much. I appreciate it. Thank you.